Algebra 2. Here we are with our first lesson from the new unit, Unit 8. Today we're going to look at multiplying and dividing rational expressions, and we're going to be doing a lot of factor and cancel. And hopefully the voice holds out today. We can get through the whole video. Might have to use this for the last class of the day. Alright, so we have 5x times x squared plus 4x plus 3 all over x squared minus 9 times x minus 6. Okay, so looking at the top, nothing to do there with the 5x. X squared plus 4x plus 3. What multiplies to 3 and adds to 4? If you need to do the x to figure it out, or factor x, go ahead. Alright, but we should come up with x plus 3 times x plus 1. Okay, across the bottom, not much to do with the x minus 6. Okay, x squared minus 9. X squared minus 9. That's a special case from earlier in the year. That is a difference of perfect squares. X squared minus 9, let x squared minus 3 squared. So we're going to break that apart into x minus 3 and x plus 3. Okay, now we look at everything after we have it all factored out, and we look to cancel. We have an x plus 3 on the top, and an x plus 3 on the bottom. So our final answer after we cancel everything out is 5x times x plus 1 on the top, and we have x minus 3 times x minus 6 on the bottom. And that's kind of the name of the game for today. Factor and cancel. Alright, for what values of that expression would be undefined? Look at the original factor denominator. So from here to here, looking back at the original problem before we simplified, our denominator was x minus 3, x plus 3, and x minus 6. Okay, we cannot have the denominator equaling 0. And because it's multiplication all the way across down there, as soon as any one of these equals 0, the whole bottom is going to be 0. So let's think about what would make these equal 0. 3, negative 3, and 6. So we don't want our x's to be 3, negative 3, or 6. Now this plus 3 in the middle does cancel out as we go, and that will be something else when we do get into graphing. Okay, we're actually going to do this part last. We're going to turn the notes page over, and we're going to talk about simplifying these monomials, or I call them chunks. Okay? Because they're not separated by anything. It's just one big chunk. Okay? So this one's a multiply, but over here we do have a divide. Okay, to divide, we're going to flip the second one and multiply. So we change our divide to multiply, and then we flip the second one, or multiply by the reciprocal. So when we're doing these, this is my strategy. I like to look at the numbers. There's no factoring because it's just one big chunk. I like to look at the numbers and see if there's any numbers I can reduce. It's multiplication, division, multiplication. So because it's all multiplication and division, we can cancel up, down, and we can cancel like diagonal, top, right, bottom, left. So I'm seeing 35 and 7. And I can divide those both by 7, and that'll make that one be a 5. Then we have 18 and 12. 18 and 12 can both be reduced by a 6. And that'll be a 2 and a 3. Now you could keep going and do the exact same thing with the letters and the variables. Okay? You could keep going and do the same thing with the variables. My experience is that then there just gets to be a lot of scratching and a lot of new things written down, and I tend to lose some things. But you could keep doing that. Okay, so now what I like to do is I'll multiply the numbers that are left. 3 times 5, that's 15 on the top. Okay, now the order of the variables that are left doesn't matter, but whatever order you use for the top, you're going to want to use for the bottom. So let's just go alphabetical. A squared, b, and then x, y to the third. Across the bottom, what do we have left? Just a 2 for the numbers. And then let's get our a, b, x, y. A squared, b to the second, x squared, y. And then now, all the letters are all lined up. It's going to make it pretty easy to reduce those. So double check, 15 over 2. Can I reduce that without going to a decimal? Nope, so I'm good there. We'll have 15 over 2. Okay, the variables. I got a squared over a squared. Well, those just cancel out. Now, what if they're not the same? Do you remember how to reduce variables with exponents? Okay, we go to where the bigger exponent is, so 2 versus 1, 2 is bigger, and then you subtract the exponents. 2 minus 1, b to the first, minus 1, is going to be 1, or b to the first, and it goes where the bigger one was, on the bottom. Same thing here, x squared compared to x to the first, 2 is bigger than 1, so we do 2 minus 1 is 1 on the bottom. And then the y's are bigger on top. We got y to the third on top over y to the first on the bottom. 3 minus 1 is 2, we'll have y squared on the top because the bigger one was on the top. And there it is. Okay? Top right, it said divide. When we're doing fractions divided by fractions, we're going to change this to a multiplication and flip the second one. So the 7a squared b squared is now on the top, and the 24x to the third goes on the bottom. And then I'm going to do a light little squiggle over that, just enough to know not to use it, but also light enough that if I mess up, I can go back and look at it to rewrite it. Okay, I want you to push pause and try to do what we did over here. Okay, let's have you push pause and give this one a go. Ready, set, pause. Okay, welcome back. Let's see how you did. We're looking to cancel out those numbers first. And I'm looking at that and seeing that 7 and 21. For whatever reason, those 7s are jumping out at me today. And that 21 is going to go to a 3. 16 and 24, we can reduce by an 8, and that's going to go to a 3 there, and a 2. Okay, and then you could keep going and doing the same thing in there with the letters. I like to do that last. So across the top, all we have is a 2, and then I'm going to keep going alphabetical. A squared, b squared, x to the first, y squared. Okay, across the bottom we have a 3 here and a 3 there. So 3 times 3 is 9. We've got a to the fourth, b to the third, x to the third. Alright, and then for our final answer, number 1, double check to make sure we can't reduce this anymore without going to a decimal. We can't, so we're good there, 2 over 9. Okay, and then our a's. A's are bigger on the bottom. 4 minus 2 is a squared on the bottom. B's are also bigger on the bottom. 3 minus 2 will have b to the first on the bottom. X's are bigger on the bottom. 3 minus 1 we'll have x squared on the bottom. And there's no other y's, so our y squared stays on top. Were you able to get that? I hope so. If not, do you see what you did wrong or what you did differently? Okay. Let's move on down to the middle row here. And this is more like the front, just that there's a lot of it. Okay, on the front side, we just had one thing. And now we have this one times this one. So there's a lot of factoring to do. Okay, I'll help you get started with the factoring. And then I'm going to push pause and let you do the fun part on your own, all the crossing out. Okay, so top left, 8x minus 20. We should be able to pull a 4 out of both things. 4 times 2x minus 5. On the bottom of that one, what multiplies to negative 35 and adds the positive 2? X plus 7 and x minus 5. Okay, top right, what multiplies to positive 10 but adds to a negative 7? X minus 2 and x minus 5. And the bottom one's a little tricky. There's a couple ways to do it. I think the easiest way is step 1, they both have a 4. They can come out. And then now I'm looking at that as a difference of squares. X squared minus 4. So on the bottom here I'll have that 4. And then x squared minus 4 should go to x minus 2, x plus 2. Okay? Now I'll let you have the fun. Go ahead and push pause and cancel out and see what we have left for our final answer. Ready? Go. Okay, hopefully you had fun slashing those out. Okay, we have the 4s that cancel out. We have the x minus 2s that cancel out. And we have an x minus 5 on the bottom and the top that cancel out. So our final answer, whatever we have left here, is we have 2x minus 5 on the top, and an x plus 7, and an x plus 2 on the bottom. Alright, time for you to spread your wings and fly. Okay, over here on the right hand side, we do have a division 1. Okay, I'm going to help you with that. We're going to change that to multiplication, and then flip it. X squared minus x minus 12. Okay, I'm going to do a light squiggle here. Just enough so my brain knows not to use it. But it's light enough that if I do screw up and I need to go back and rewrite the problem, I can still see what that is. Alright, go ahead and push pause and give the whole thing a go. Okay, welcome back. Let's check it out. Okay. So I have x minus 4, x minus 5 for the top left. Bottom left, I have x plus 3, x plus 7. The new top right is going to be 6 times x plus 7. And the new bottom right is x minus 4, x plus 3. Okay, then we're going through and canceling. We have x minus 4 on the top and bottom, and x plus 7 top and bottom. So I have 6 times x minus 5 on the top, x plus 3, and another x plus 3 on the bottom. Very tempting to cancel those out, but they're both on the bottom, so we can't. Okay, you could combine them together to be x plus 3 squared if you wanted to write it that way, but we cannot cancel them out. Okay, just a quick note here, we're not going to do this one, but if you do see something like this, fraction divided by fraction, we're going to change it to multiplication and flip. So that 2x minus 5 would be on the top, and the x squared minus 4 is on the bottom. Okay? That's what that big giant fraction there is. It's a fraction divided by a fraction. So it's just like the one we just did. Alright, we are going to go back to the front now and get that special case. Simplifying with a negative 1, or getting tricky with a negative 1. Okay, So here we are, we're simplifying, it's all multiplication. Okay, what can I pull out of the first one? Well, there's an x in both parts of the first one. So we take an x out in front. And we'll have 4x to the first now, because I took one of them out, minus 3y. And then we have x plus y. Across the bottom, we have our 3y minus 4x. Very close. Not quite the same, just a little bit. See how they're just spun around the minus sign? And that's what this special case is going to be about. Okay, so that's all the factoring that I can do. I didn't get to cancel anything. That's no fun. So if you have the exact same things, but they're just backwards around the minus sign, here's what we're going to do. Okay, we can't cancel those out. They're not quite the same thing. Let's think like 10 and 2. 10 minus 2 is 8. Turn it around, 2 minus 10 is negative 8. So if things are turned around the minus side, they're going to be the exact same number, just opposite signs. So what does positive 8 divided by negative 8, or negative 8 divided by positive 8, equal? It should leave us with a negative 1. So the shortcut is, if we find that these are spun around a minus sign, we can cancel them out and then leave a negative 1 behind. Okay, here's why that works. Here's why. Okay, we have our x. And I'm going to take a negative 1 out of this. We're going to take a negative 1 out of that parentheses. So if I pull a negative 1 out of both of those, that's going to be a negative 4x and a plus 3y. Okay? Still have the same thing on the bottom. Now, a plus, you can turn them around. 2 plus 8 is 10, and 8 plus 2 is 10. You can turn them around. Okay, so now I'm going to turn it around. I'm going to do x times negative 1, that's going to be negative x. And we're going to spin that one around, so the 3y's in the front, plus a negative 4x. And 3y plus negative 4x is the same as 3y minus 4x. And now they'll cancel, and we'll have negative x plus y on the top, over 5x plus y on the bottom. Okay, so that's why you can do that negative 1 trick. Okay? Otherwise, you could do the hack of, if you have two things that are the same, but they're just flip-flopped on the minus sign, you can cross them out and leave a negative 1 on the top or the bottom, whatever is more convenient for you. Okay? That should be good to do your work. I know we had 2 on the other side left to go. If you want to try simplifying that negative 1 on your own, you can give this one a try, and I'll throw that up here at the end. I know we had 2 more to go on the back, but they're pretty similar to ones we already did. It's just with flipping with the second one. So you should be good to go. If you do want to try this one on your own, go ahead and push pause, and I'll put up the answers here right afterwards. Okay, here's the answers to that last one. If you did that one on your own, let's see how you did. And good luck with your homework tonight. Thanks a lot for watching. Let me know if you have any questions.